Abhishek Sharma.
I'm Neeraj Oza.
And I'm Prachi Jain. There is no system in the market today that monitors a house or a building for temperature and natural gas levels simultaneously to shut off the wall system and prevent explosion.
Our idea could prevent any potent Bhopal gas tragedy in the future that could hamper industries, buildings, houses, and eventually the country's growth.
This motivated us to make our project on the automated gas shut-off wall system.
This is the generalized assembly of how our circuit works. We have used LPG as the natural gas. Now the LPG gas is supplied to this solenoid valve. Now this valve is connected to the main microcontroller. We have used a gas burner that gives us the indication of how well the gas supply is being made from the LPG cylinder. Now right above the burner we have this sensor. This sensor detects any kind of leakage going on from this gas burner. Now as soon as this sensor senses the leakage, this alarm goes off with the help of that microcontroller, which gets the data from this sensor. Now as soon as this alarm goes off, the main power supply that is being indicated by this lighted region, the main power supply also goes off as soon as this main alarm goes off. Now how we cause the system to work is like this. We turn the gas supply on and the burner is on. Now we turn the burner off. Now this gas burner senses, the alarm goes on, and the main supply is now about to be cut, and this is how it is cut. Now even if we try to light the burner now, the burner doesn't light, and this is how the entire system works.
Here, this is our power supply section. We are using DC power supply for controlling the whole power for our assembly. We are using plus 9 volt batteries. We can use alternative DC power supply for our circuit. This is LM317M voltage regulator IC, which gives the regulated output voltage. At this point of our breadboard, we are getting plus 9 volt. At this point, we are getting minus 9 volt, and at this point, this is a common ground. Now, plus 9 volt is inputted into the LM317M voltage regulator IC. We can get adjustable output with the help of this potentiometer. The output range can be plus 4 volt to plus 12 volt. Now we will see how it will work. At this point we are getting approximate 9 volt, which is 8.3 volt. Now this is inputted into the voltage regulator IC input. At this point we are getting 5.1 volt, which is nearly about to the 5 volt. As we seen that our power section unit is giving a plus 5 volt by using LM317M voltage regulator IC, which is required for our sensor unit. Our sensor unit contains temperature sensor LM35, which detects the temperature, and the LPG gas sensor MQ6, which detects the LPG gas. Now the output of the LM35 unit is in millivolt. To amplify its output, we are using a OPA277P IC, which is the op-amp, and to compare this output with the reference voltage, we are using a SAM OP277P IC as a comparator. It compares the output from the temperature sensor to the reference voltage and gives the negative saturation and positive saturation. To clip the negative saturation, we are using here a diode, and to regulate, we are using Zener diodes. Now we will make connections. It's a plus 9 volt to the op-amp, minus 9 volt to the fourth pin of op-amp, and its common ground, and the 5 volt from the output of our regulator IC given to input of our sensor. Now we will see the output at the sensor. It's giving up 0 voltage when there is no temperature. Now, by increasing the temperature, it goes to the 4 volt, which is a positive saturation. It will be the input for our microcontroller MSP430. The same circuit is here for our gas sensor, and it's a complete IC for our gas sensor. Now move to the next step, which is our controller unit. We are using MSP430G2231 microcontroller here. The output coming from the sensors are given to the input ports of our controller unit, and at the output ports we have a buzzer, LED, and 2 relay switches which will control our solenoid valve and the main output power supply. Now in controller unit we are having this section for reset switch and this section for VCC. This port is defined for our VCC. These 2 ports are for our input and these 2 ports are for our output. Now we are combining all our sections and making our general assembly for the working model of our project. Here our power section, this is our sensor unit, this is our control unit, and this is our output unit, which containing the 2 12 volt 1 and 1 NC relay. And this is our main power LPG gas source. This is our main power supply, and this is burner for showing the fluence of our gas. And now we will demonstrate the working with temperature sensor first, and after that gas sensor.